Right, section 9.3, part 1. We've talked about a lot of different sequences so far, and we really have only given one a name. Um, some of the sequences that we've talked about, in section 9.1, one of the sequences we looked at was maybe squares. So something like 4 and 9, 16, 25, 36, okay? So our formula for this, our a sub n, might be n plus 1 squared. Okay, so something like that. And again, we didn't really give this a name, or we had 1, 2, 6, 24, 120. So if you remember, this one is simply the factorial sequence, so that was n factorial. And then we talked about some that we gave a specific name. So we might have had 5, 10, 15, 20. And this is going up by 5 each time. And we learned that this is called arithmetic. So this would be a sub n is equal to 5n. So today's video, we're going to talk about another specific type of sequence that we're going to give it a name. And this is called a geometric sequence. So our definition of a geometric sequence, a sequence is geometric if the ratio of consecutive terms are equal. This should be ratios. Ratios of consecutive terms are equal, and this common ratio, we're going to give it the letter R. So similar to what we did with arithmetic sequences, except that was a common difference, so we were adding or subtracting the same thing to get to the next term. Now we're going to be multiplying or dividing. So we don't have a common difference, we have a common ratio. We're not going to call it R, we're going to call it D. So for example, let's look at a simple one here. Let's say we had 2, 6, 18, 54, and so on. To get consecutive terms, multiply by 3. So that would mean R, our common ratio, is equal to 3. So one of the nice things about arithmetic sequences and geometric sequences is that we have a pretty straightforward formula for each of them. Again, if you remember in section 9.1, we kind of had to experiment, we had to guess, we had to do a little bit of guessing and checking. With arithmetic sequences, we knew that a sub n was equal to a sub 1 plus d times n minus 1. So our nth term of a geometric sequence we're going to have a formula also. Our book still uses a sub n for geometric sequence, but I like to use g. So I'll try and be consistent with that. So g sub n, again, this is just a formula, just like f of x would be a function. G of n, it's a function as well, except we're only using integer values to plug in. So g sub n is equal to g sub 1 times r raised to the n minus 1. So you see some similarities to the arithmetic sequence. Instead of a sub 1, we have g sub 1. And instead of multiplying our common difference times n minus 1, we're taking our common ratio and raising it to the n minus 1. Alright, so really that is the basic formula for finding the nth term of a geometric sequence. So let's take a look at a couple examples, starting out with something as basic as find the first 5 terms if g sub 1 is equal to 3, and r is equal to 2. So we've got our first term. All we need to do is find the second, third, fourth, and fifth. So since g sub 1 is 3, g sub 2, it's going to be 2 times the first term, because really we're just going to multiply by 2 each time, so that's going to be 6. And then g sub 3, that's going to be the second term times 2, so 2 times 6, so that's 12. And g sub 4 is going to be 12 times 2, 24. And then g sub 5 is going to be 2 times 24, or 48. So if you look at the whole sequence here, we had 3, 6, 12, 24, 48. So you notice to go from one term to the next, we're just multiplying by 2 times 2 times 2 times 2 times 2. So we're either going to be multiplying or dividing by the same number to get to the next term. Alright, next example. Let's find the nth term and the 15th term. Okay, so remember, the nth term, really, this is just a formula. And then once we find that formula, we're going to plug in 15 and find the 15th term. And we know, we are given some other information, the first term is 20, and the common ratio is 1.05. So again, our formula for the nth term of a geometric sequence, g sub n is equal to g sub 1 times r raised to the n minus 1. So we know what g sub 1 is, we know what r is, we're just going to substitute those in, so g sub 1 is 20. So we know that g sub n is equal to 20 times r, which is 1.05, raised to the n minus 1. So it's a little bit more straightforward even than arithmetic. With the arithmetic sequence, we had to do a little distributing and combining like terms. Here, you're just going to leave it like this, because if you remember order of operations, we have to do the exponent first, then we'll multiply by the 20. Alright, so this is the first part. This is the nth term. Nth term. Okay, now we want to find the 15th term, so we want g sub 15. So now we've got 20 times 1.05 raised to the 15 minus 1. Now, I would recommend doing the 15 minus 1 in your head to simplify the calculations in your calculator. So go ahead and plug that in. We're going to round it to one decimal place. And you should get 39.6. So feel free to pause, double check that you can get that number. If you're not getting that number and you can't figure out how, make sure that you ask in class. Alright, let's try another example. Again, after we write down the problem, if you want to pause and try it on your own, then you can restart the video and check. So, example, find the nth term and the 12th term. Alright, and we're given the sequence 5, 15, 45, and so on. So our formula for the nth term, again, is g sub n is equal to g sub 1 times r to the n minus 1. So we need the first term and we need the common ratio. Well, if we look at the sequence as it's given, we know what the first term is. That's just simply 5. And then we can figure out the common ratio because to go from 5 to 15, we're multiplying by 3 times 3. To go from 15 to 45, we're multiplying by 3. So my common ratio is 3. So my nth term is going to be the first term, which was 5, times the common ratio, which is 3, raised to the n minus 1. Again, no simplifying to do. So that's the first part of the problem. We found the nth term, which is our formula. Then we're going to plug in 12 because we wanted the 12th term. So g sub 12 is equal to 5 times 3 raised to the 12 minus 1. Do the 12 minus 1 in your head. plug that into your calculator. 5 times 3 to the 11th. And hopefully you get 885,735. Okay, one more example and then we'll be done with this video. A little bit more difficult. We've got a couple of steps that are involved. So for this one, we're given that the fourth term, g sub 4, is 125, and we're given that the 10th term is 125/64. Okay, and we want to find g sub n, so we want to find the formula that will generate the terms in the sequence, and we want to find the 14th term. So we're going to go through a process that's similar to what we did with arithmetic sequences. There's a relationship between the 10th term and the 4th term. So to get to the 10th term, how many times do I have to multiply the 4th term times r? Well, I've got to go from 4, 5, 6, 7, 8, 9, 10. So I'm going to have to multiply by the common ratio 6 times. Remember, repeated multiplication, we use exponents. So this 6, really, it just came from 10 minus 4. Okay? And I know what g sub 10 is. That's 125/64. And I know what g sub 4 is. That's 125. So I can find r. So I've got substituting in 125/64 is equal to 125 times r to the 6th. So let's see, I'm going to multiply both sides by 1/125. That's the same as dividing by 125, so that's going to be 125/64. Again, you could do most of this on your calculator, and then 1/125 times 125 times r to the 6th. So these are going to cancel, these are going to cancel, so I'm left with 1/64 is equal to r to the 6th. So what I need to do is I need to take the 6th root of both sides. So if you remember from algebra, the 6th root, so I'm going to take the 6th root of 1/64, and I'm going to take the 6th root of r to the 6th, and in algebra this is the same as raising it to the 1/6 power. So this is the same as 1/64 raised to the 1/6 power. Okay, and this is r to the 6th raised to the 1/6 power. So these cancel each other out, and then we just have to plug this into our calculator. If you think about this, what number do I have to multiply by itself 6 times to get 1/164? You know, if you can't figure that out, you could easily do it on your calculator. You know, so on your calculator, you're going to have 1 divided by 64 raised to the 1 divided by 6, and it's going to tell you 0.5. Okay, or I'm going to leave it as a half. So now that we know what r is, this is r, okay, because we solved for r over here. So this calculation here is this. I'm going to do the same process, except I have to find g sub 1. So now find g sub 1. Okay, so I'm going to use the 4th term, so I know I'm going to use the same type of relationship. I know g sub 4 is equal to g sub 1 times the common ratio. How many times? Well, we go from 1 to 4. It's 3 times. Substitute in what I know. I know the 4th term is 125. I don't know the 1st term, but I did figure out that r is 1/2, or you could put in 0.5 if you want. So in the interest of trying to save a little bit of time here, I'm going to solve for the 1st term, g sub 1, it's going to be 1,000. If you don't get that or you can't figure out how, make sure you ask me in class. And now that I have g sub 1 and I have r, I can find g sub n. So g sub n is going to be the 1st term, which is 1,000, times the common ratio, which is 1/2, raised to the n minus 1. Or if you wanted to write it as 1,000 times 0.5 raised to the n minus 1, that would be acceptable as well. Alright, and we also had to find the 14th term. So g sub 14 is going to be 1,000 times 1/2 raised to the 14 minus 1. Plug all that into your calculator. If you're looking at a fraction, it's going to be 125 over 1024. Not sure what that is as a decimal, but if you do a math enter on your calculator, you can figure out what that is. So, as always, make sure you write down any questions that you have and ask me in class.